Hi everyone. Today we are going to learn about estimating a population mean using a confidence interval. By the end of this lesson, you will be able to state and check the random 10% and normal large sample condition for constructing a confidence interval for a population mean, explain how t-distributions are different from the standard normal distribution and why we need to use t-distributions for estimating a population mean, determine the critical values for calculating any percentage confidence interval for a population mean using the table or your calculator, construct and interpret a confidence interval for a population mean, determine the sample size required to obtain a desired confidence interval for a population mean with a specified margin of error. So let's start with an example. Suppose I want to know the typical American family's average grocery bill for Thanksgiving dinner. I will start by taking a simple random sample of 30 families' grocery bills and calculating the sample mean. Okay, and we had X bar to be $51.20. And our sample standard deviation, SX, was $3.23. So our sample mean, X bar, is an unbiased estimator or point estimate of the unknown population mean, mu. So I would estimate the population average to be approximately X bar, since it's unbiased. However, using a different sample would have given a different sample mean, so I must consider the amount of variation in the sampling model for X bar. Based on one sample, it would not be correct to conclude that the typical American family's average grocery bill is $51.20. Instead, we want to use our statistic, or our X bar, to estimate the population mean, mu, by creating a confidence interval. And remember, the interval is a range of numbers. If our data comes from a simple random sample and the sample size is sufficiently large, then we know that the sampling distribution of the sample means is approximately normal with a mean of mu and a standard deviation of sigma over the square root of our sample size. But we have a problem. If we don't know sigma, we can't calculate the standard deviation for the sample model. So we need to estimate the value of sigma in order to use any methods of inference that we've learned. So our solution, we are going to use SX, the standard deviation from our sample, to estimate sigma. With SX as our estimate, now the standard error of the sample mean, X bar, will be SX over the square root of our sample size. Notice it's very similar to the formula we had in Chapter 7 for the sampling distribution of sample means. Before, we use the normal distribution with z equals your statistic minus your parameter over your standard deviation for your statistic for the distribution of sample means, because we knew the standard deviation of the population. Okay, but if we do not know sigma and we replace it with SX, then our statistic has more variation and no longer has a normal distribution. So we can't call it z, and we cannot use z-scores or z-star. So now X bar will have a new distribution called the t-distribution. T star is going to be our new standardized value, like z star. It tells us how many standardized units X bar is from the mean mu. When we describe a t-distribution, we must identify its degrees of freedom. Because there is a different t-statistic for each sample size. The degrees of freedom for the one sample The t-distribution is symmetric about 0 and is bell-shaped, but there is more variation, which means that the spread is greater. Centered about 0, greater spread. As our degrees of freedom increases, the t-distribution gets closer to the normal distribution, since t is getting closer and closer to z. Okay, so how do we calculate our t-star value? Okay, using the table, okay, if you look, it's always going to give you the area shaded to the right. Your degrees of freedom is on the left-hand column, and at the very bottom is our confidence level, okay? So first, say we wanted to be 90% confident, and we had 80 degrees of freedom, okay? Find the 90% confidence column, okay? 80 degrees of freedom, find where they meet, and your t-star would be 1.664, just as an example. So let's talk about how we can actually construct the confidence interval using the t-distribution. It's the same way we constructed our confidence intervals for the z-distribution for proportions, and we're still going to use the same general formula of your statistic plus or minus your critical value times your standard error. Remember, this is also called our margin of error. Okay, now using this formula and putting in our symbols for means, our statistic is x bar, our critical value is now t star, and then don't forget we're using s instead of sigma for our standard deviation. Now our margin of error is always going to be a positive integer that we add or subtract from our statistic to get our confidence interval. We can use a specified margin of error to determine the sample size that will obtain a desired confidence interval for a population mean by solving the equation for n. This is a great question that you may see as a multiple choice on an AP exam or on a quiz or a test. Remember, the t-table uses the area to the right of t-star. It is also table T3 in your textbook. One sample t procedures are exactly correct only when our population is normal. It must be reasonable to assume that the population is approximately normal in order to justify the use of t procedures. The t procedures are strongly influenced by outliers, so we always want to check our data first. If there are outliers, and your sample size is small, we're not going to get reliable results. So we wouldn't get a reliable confidence interval. So when do we use our t procedures? If our sample size is less than 15, do not use t procedures if the data shows severe skewness. If the sample size is at least 15, but less than 30, only use t procedures if the data is unimodal and reasonably symmetric. Now, if your sample size is at least 30, you can proceed to use your t procedures even if your data is skewed. So 30 or more, you are good to go. Okay, so putting it all together in our state plan do conclude four-step process. When you're doing a confidence interval for one sample mean, state say the parameter we're trying to estimate. In this case, we're trying to estimate mu. And what confidence level are we estimating? Are we estimating at 90% confident, 95, 99? You have to be clear and say what kind you're estimating. Plan. Identify the inference method and check your conditions. Make sure you say these in context. Context is big. It's the difference between E's and P's and 2's and 4's on AP problems. So our first assumption, we need to have a random sample, okay? Or our values, also known as being independent of each other. If we don't know that our sampled values are independent, then our sample size needs to be less than 10% of the population. Just like we had in Chapter 7, nothing's changed there. Second, we need to have a big enough sample, and we have to meet the normal condition. If we know the population distribution is normal, so is the sampling distribution of our sample means. This is true no matter what your sample size is. However, if we do not know anything about the population distribution, we don't know if it's normal or not, our central limit theorem tells us that the sampling distribution of your sample means will be approximately normal in most cases if your sample size is greater than 30. If your sample size is less than 30, then you have to check the data to make sure that it is roughly symmetric, unimodal, and has no outliers. Once we've met all of our assumptions and conditions, we can start calculating our confidence interval. If our conditions are met, we can construct a whatever percentage confidence interval you're looking for one sample mean. It's very important to name what kind of interval you're constructing. Okay? Show our interval with our statistic plus or minus our critical value times our standard error. And then state your conclusion, which also needs to be in context. It's very, very important. Okay, so what is our interval and what does it say? Okay, I am, for example, 90% confident that the true mean or average of whatever we're talking about falls within, and then you state your interval. Okay, now if they ask you to interpret your interval, so what does your interval mean? Okay, 90% confidence means that in several random samples of whatever you're talking about, of whatever your sample size is, 90% of the intervals produced from those samples will contain the true mean or average of an input, your context. Okay, and 90% was just an example. So let's try a practice problem. Think back to our Thanksgiving example. We had a sample of 30 families. Since it's 30, we are okay to use T procedures and construct a confidence interval with our sample mean of $51.20 and standard deviation of $3.23 to estimate the actual average Thanksgiving grocery bill. Okay, if you see construct and interpret a confidence interval, you are doing a confidence interval, not a test. We'll get to tests later. So we are constructing and interpreting a 95% confidence interval for the average Thanksgiving grocery bill for the typical American family. So let's state what we're trying to find in context. We want to estimate the true average Thanksgiving grocery bill for the typical American family. And we have to add in how confident we want to be when we make that estimate. So we're going to make that estimate with 95% confidence. Very important you say your confidence level in your state. Okay, I've said what I'm trying to find, let's check our assumptions and conditions. I know I have a simple random sample of 30 families, so we can say we have a random sample of 30 families' grocery bills. Next, okay, we don't know if the population distribution of all grocery bills is normal, but we know our sample size is greater than 30, so our sample size is large enough that we can proceed with T procedures. Okay, since all of our conditions are met, we can apply the t-distribution and construct a 95% confidence interval for a one sample mean. All right, let's make our interval. Okay, remember, we're going to use our statistic plus or minus our critical value times the standard error. Okay, and that's going to be our equation for our means. Now, we know our X bar is $51.20. T star, I need to find that using my degrees of freedom. Okay, my degrees of freedom is my sample size minus 1. So for this problem, my degrees of freedom will be 29 since I had 30 grocery bills in my sample. Now, using your table for T star, okay, I want to be 95% confident and my degrees of freedom is 29. So if I follow along that row till I get to 95% confident, I can see that my T star value is going to be 2.045. Okay, now I'm going to use my statistic for my standard deviation, which was $3.23 over the square root of my sample size, which was 30. Okay, now calculating that interval, we're going to get 49.99 to 52.41. Okay, if you are doing this in the calculator, okay, the test you would want to run would be a t interval. For one sample, and that would give you the same result as if you did it by hand. Okay, so now that I have my confidence interval, I can say my conclusion. Okay, so what did we find? Okay, we are, or I am, 95% confident that the true or actual average grocery bill for Thanksgiving falls between, and and then I'm just going to state the interval I calculated in my do. And since we're talking about money, we can add the money in there. Now, if they only asked you to conclude, you would be done. Since they asked us to interpret, we need to say, what does it mean to be 95% confident? Okay, so 95% confidence means in several random samples, of 30 grocery bills. So remember, the samples all need to be the same size. 95% of the intervals produced from those samples will contain the true average cost of the Thanksgiving grocery bill. So that looks like a lot of wording, but if you think about it, if you took several random samples and you constructed a confidence interval for each of those, say you took 100 samples, okay, and you made 100 confidence intervals and you're estimating at 95% confidence, 95 out of those 100 samples will contain those true average costs for the Thanksgiving grocery bill. 95 of those intervals out of 100. And that is all for today.